All right, today we're going to talk about something that almost every rider thinks is just common sense, but we're getting it wrong. Well, it can be seriously dangerous. We're talking about riding in extreme heat. And we're about to get into some pretty counterintuitive science that shows why wearing more gear, not less, might just be the thing that keeps you cool and safe out there.
I mean, of course you have, right? It's that classic advice you hear at every single gas stop once the temperature starts to climb. You know, the sun's beating down, the asphalt is basically a giant heater, and the logical thing to do is shed layers, right? Well, that piece of common wisdom, it's not just wrong, it's a recipe for some real trouble.
Yeah, believe it or not, science actually proves that stripping down to a t-shirt in triple-digit heat doesn't cool you off. It does the exact opposite. It actually speeds up the very things that lead to severe dehydration and heat stroke. So how is that even possible? Well, the answer comes down to one single critical temperature.
Okay, burn this number into your brain. 93 degrees Fahrenheit. That's about 34 Celsius. Why is that number so important? Because on average, that's your skin temperature. And it's the exact point where the whole game changes and the wind goes from being your best friend to, well, your worst enemy. Let's break down how your body's own air conditioning system really works.
So your body has this amazing four-part toolkit to keep its core temperature stable. You've got conduction, that's heat transfer from direct contact. You've got radiation, where you're just shedding heat waves into cooler air. Then there's convection, which is the cooling effect of wind rushing past you. And of course, the one we all know and love, evaporation. That's your sweat turning into vapor and pulling heat away with it.
Now, this is what's so fascinating. Just look at the huge shift you can see on this slide. And that image on the left, at a really pleasant 80 degrees, two of your biggest tools, radiation and convection, are doing all the heavy lifting, just carrying your body heat away. No problem. But then, look at the image on the right. The second the air temperature matches your skin temperature at 93 degrees, those two methods just stop. They grind to a complete halt because they can't work without a temperature difference.
So, here's the absolute crucial takeaway. Once that air hits 93 degrees, your body has lost its main ways of cooling itself down. The only tool left in the toolbox is evaporation. Your ability to survive the heat now comes down to one thing and one thing only: how efficiently you can sweat.
And this is where everything you thought you knew about riding in the heat gets turned completely upside down. Once the air is hotter than your skin, that wind you feel at 65 miles an hour, it's no longer a cool breeze. It's a convection oven. Seriously. The wind is now actively forcing heat into your body, adding to the heat your own metabolism is already making.
This quote from the Iron Butt Association's research just says it all perfectly. We all get wind chill, right? How wind makes cold feel even colder. Well, this is the exact reverse. In extreme heat, that strong wind is like a blowtorch, just dramatically cranking up the thermal stress on your body.
Okay, so if the wind itself becomes the enemy once you're over 93 degrees, how in the world do you defend against it? This is where your gear strategy has to completely flip. We're about to see why a proper jacket isn't just armor against the asphalt, it's armor against the air itself. Okay, let's just compare them head to head. You're riding in a t-shirt. That high-speed wind literally rips the sweat off your skin the second it appears, way before it has a chance to evaporate and actually do any cooling. So what does your body do? It senses it's not cooling down, so it just produces more and more and more sweat, and you dehydrate incredibly fast. Now contrast that with a vented jacket. It creates this personal little microclimate around you. It blocks the direct sun, and most importantly, it manages the airflow. The wind gets slowed down, which allows your sweat to finally do its job and cool you effectively, all while using way less of your body's precious water.
So how do you make that microclimate even better? Well, the secret is all about what you wear underneath. Moisture-wicking base layers. They basically act like a second skin. They hold your sweat right up against you where it needs to be so it can evaporate efficiently instead of just dripping away and doing nothing. And a wicking helmet liner? Oh, that's absolutely critical, since a massive amount of your body's cooling happens right through your head.
All right, so now we've got the hardware, the gear, all set up correctly. Now we got to talk about the fuel for this cooling system, water. And the amount of fuel you need when it gets truly hot, it's absolutely staggering. Okay, just take a look at this chart. This shows what your body needs on a 4-hour ride. At 80 degrees, it's about 12 ounces. Totally manageable, right? But just watch what happens. At our magic number, 93 degrees, your water requirement more than triples to 1.3 quarts. Bump it up to 103, and you're looking at nearly 3 quarts. And at a blistering 113 degrees, well, that number is so crazy, it deserves its own slide. 1.1 gallons. Let that sink in. That is the minimum amount of water your body is going to sweat out in just 4 hours. It is an almost impossible amount of fluid to try and keep up with. If you're waiting for gas stops to rehydrate, you will fall dangerously behind. Period. There's no way around it.
And this is exactly why, for any kind of serious hot weather riding, an on-bike hydration system, like a Camelback, isn't a luxury item, it is essential life support equipment. You have to be sipping water constantly, long before you even begin to feel thirsty, just to fight what is honestly a losing battle against dehydration.
So what happens if your body's natural cooling system, even when you're managing it perfectly with the right gear and hydration, what if it's still not enough to keep you safe? Well, that's when we can turn to some pretty clever technology to get an extra edge against that heat.
So there are basically two main types of cooling vests out there. First, you've got your evaporative vests. They're simple, you soak them in water, and they basically give you a supplemental supercharged evaporative cooling effect. They work great for shorter trips, especially in dry heat. Then you have the heavy hitters, phase change vests. These use special packs you actually charge in a freezer, and they maintain a constant, cool temperature for hours. They are the go-to for long distances or for when the humidity is so high that normal evaporation is almost useless.
So let's just put this all together into a simple pre-ride checklist. Number 1, minimize that direct wind. Use your windscreen, use your suit, do whatever you can to stop that convective heating. 2, wick your sweat. Use those base layers to make every single drop count. 3, hydrate relentlessly. Get an on-bike system and just drink constantly. And 4, this is a big one, insulate. Protect your legs from that direct engine and radiator heat, which can get hot enough to actually cause contact burns. Ultimately, it really all comes down to this one question. Every single responsible rider gears up for a potential crash, right? But on a 100-degree day, the heat isn't a potential threat. It's a definite and immediate one. Being truly safe means being geared up for the ride itself, and that includes the temperature. So rethink your gear, respect the heat, and ride safe out there.